professor of biology at Northern Virginia Community College and a research associate at the Smithsonian National Museum of Natural History. Paleontology provides a glimpse of a deep history of life. It captures the processes that take place at scales that we cannot observe in our own lifetime. So the patterns that paleontology reveals, paleontology is the only source for us to observe and study such patterns. And as somebody said, that paleontology tells you, it doesn't tell you the whole truth, but it tells you nothing but the truth. So for us in evolutionary history, that's one of the sources of empirical information that is that's certainly beyond doubt. Of course, we can interpret it in many different ways, but if something appeared at that time, we see it in the fossil record, it means it was there. So we have to account for it. Microevolution, by formal definition, is the change in gene frequency in individual populations. And traditionally, that has been an explanatory framework to understand evolutionary processes at all scales. And now we're quite convinced that this is not the entire story. So microevolutionary processes certainly do take place, but they don't account for the large number of phenomena that we see in life that characterize the diversity of living organisms. Traditionally, microevolution has been viewed as a population-level processes, where the macroevolutionary phenomena is something observed at the level of species and above. And the whole question was whether you can explain the macro events from the standpoint of microevolutionary processes or not. And we now realize that this large-scale phenomena frequently cannot be reduced to more simple explanations at the level of lower-level entities. If you reduce because it means you're making a sharp difference between events at the population level and above, but there are some processes that are unique to levels of organization that below populations, and then you have to have microevolution and mega evolution. So then you have to have special words for evolutionary processes that are unique to different levels of organization. So I think making it dichotomous creates a false distinction between only separating two sets of phenomena, but there are many more. Hierarchy theory is an approach to understand biological complexity by considering very seriously the ontology of the structure of the natural systems. And the hierarchy theory recognizes that living organisms, living systems rather, they're made from parts, and those parts in turn are made from other parts that interact with each other in a non-trivial ways. And trying to unveil these relationships requires some way of decoupling these levels from one another, and that's what hierarchy is saying. Hierarchy theory is, in my opinion, it provides an adequate framework for viewing biological entities in the entirety. So it's in itself, it doesn't have it provides an explanatory work for diversity of evolutionary processes that subsumes everything that has been proposed in light of the modern synthesis of evolution, but it builds upon that, introduces a set of phenomena that were not addressed by the modern synthesis perspective. Well, I believe that extended synthesis is an attempt to use evolutionary framework to encompass an entire range of phenomena that fall within the definition of evolution as fate of transmissible information through time. And that would include also cultural phenomena as well. And some of process of cultural change are undoubtedly evolutionary. And in that sense, extended synthesis provides the framework for real interdisciplinarity, for actual interdisciplinarity, which was at the root of evolutionary theory from the start. If you think of Darwinian contribution, he relied greatly on some very fruitful analogy between biology and economics. And here we can now almost make a reverse contribution to the fields related to sociocultural evolution by taking some of the significant advances in our understanding of biological processes to explain process of change in culture. My empirical work focuses on evolution of mollusks. Mollusks are one of the most wonderful groups to study evolutionary processes for a number of reasons. So first, their scale, as you can see from some of the specimens here, is comparable to ours. We can observe many features with the naked eye. They are on physical scale that is easily amenable to research. Then they have extensive fossil record. Most mollusks are shelled organisms, and shells preserve very well. The group of animals that I study, pearl oysters, that go back to the lower middle Ordovicians. It's a very ancient group. And the advantage of studying something that has such a long history is the ability to catch some of the historical processes that we cannot observe at our own time scale. And having a group of organisms which still exist in the present, so we know quite a lot about mollusks and how they live, how they utilize their resources, how they model their shells. We can infer what could be the driving forces in the past that made them what they are through changes in their evolutionary history. Well, apart from being a practicing biologist, I'm also a musician, and it has always been fascinating by the history of musical instruments. And to me, when I look at some instruments that have been played in the past and seeing that they look almost nothing like what we have now, there must be some process of change that have taken place in history that led to changes in maybe in taste in musical practices that could probably be explained by the application of evolutionary theory to culture. And I have attempted to address this several years ago in my attempt to reconstruct the history of one particular instrument that I'm deeply interested in, that I do play, as well as I have reconstructed some copies based on archaeological and ethnographical specimens. It's called the Baltic Psaltery. It's a string instrument played in northwestern Europe by the Balts, Finns, and Slavs. They're called usually by regional names, like Kantele is the Finnish name for it. And what was interesting to me is that the instrument themselves, in their structure and the elements of decoration, there was some elements of ethnic identity that made these instruments become symbols of national identity for all the people that play them. And I attempted to use some traditional methods of phylogenetic reconstruction to investigate the history of this instrument from the Middle Ages, the time when we see this instrument for the first time in the archaeological record, and up to the present. It's still played in some parts of some remote villages in Russia and Karelia in Finland. And so far from I can see this work was very fruitful. It certainly brought to light some interesting aspects in the history of these instruments, but also it made me realize that there are some elements of history in culture that we cannot explain by application of simple traditional biological methods, that there is some peculiarity to it. So there are parallels that definitely exist between biological and natural world. How far these parallels can be taken to transfer the processes, biological processes, from nature to culture is a different question. There are parallels, and we're still in the process, largely in the process of investigating how similar these these modes of evolution are. I was very surprised that I was not the only person thinking about the evolution of, not just of material culture, but of musical instruments specifically. And to my surprise, a colleague in my home institution at the American Museum of Natural History down the hall was Dr. Niles Eldridge, who contributed greatly not only to the contemporary evolutionary theory with the punctuated equilibrium hypothesis that he proposed with Stephen Jay Gould, but also to our understanding of material cultural evolution. So we teamed up and wrote a paper together on the application of phylogenetic methods in material culture. It was published in Current Anthropology under the title Phylogenetics and Material Cultural Evolution. And I think it might be a good starting point to highlight some conceptual differences between material and cultural evolution.